Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 9 from the May-June 2020 Cambridge 9709 A-Level Paper 1, Variant 3. This is a pure math paper. And here we've got a question all about functions. And I'm going to go into some detail about this question because this is a topic where many students have certain kind of weaknesses and misunderstandings. And, I've got those questions that students have asked me in mind as I'm answering this question. So some of the questions in the exams will take you seconds to answer, but understanding what's behind it is what I am concerned about in this video. Not about how quick it should take you in the exam, but giving you the understanding behind the question so that when you get to the exam, you'll be able to answer it, properly and with proper understanding and correctly. All right. So now we have these functions f and g. F of x is x squared minus 4x plus 3 for x is greater than c. So the domain of f of x is limited for x is greater than c, where c is a constant, which we don't know at the moment. And g of x is 1 over x plus 1, which is like a reciprocal function for x is greater than negative 1. So we have a quadratic function, f of x, and a reciprocal function, g of x. They both have restricted domains. For g of x, we know it's restricted for x is greater than minus 1, but f of x, we don't know. We're going to probably have to deal with something to determine what c is, or we will be told what c is. So it says first, express f of x in the form x minus a squared plus b. So quadratic expressions can be expressed in this form, which is a very useful form, as we will see. This is called the completing the square form. When the square has been completed for this, you end up with a square bracket and just one x term inside it. And that's very useful for us for a few different things, as we will see. So we start off with f of x as our quadratic x squared minus 4x plus 3 in this form, ax squared plus bx plus c. When we want to complete the square, we have to ensure that the x squared term has a coefficient which is a perfect square. In this case, it's 1, which is a perfect square. That's fine. So then we can proceed and complete the square. So I'm going to write a bracket squared. The square root of the x squared term goes in here, so that's going to be x. The sign between the x squared and the x term comes next. And then the coefficient of the x term is halved and placed inside the bracket, just the coefficient without the x. Now this is something that if I expand, it will give me x squared minus 4x, but plus 4. I want x squared minus 4x plus 3. So let's ignore the 3 for now. I want x squared plus 4x from this. So this will give me x squared plus 4x. Sorry, this will give me x squared minus 4x, but then it will give me plus 4. So I've got to take away that 4. When I expand this, I'll get x squared minus 4x plus 4 minus 4, which gives me 0. So this is exactly the same as that up to this point here. They're the same. But then I have a plus 3 at the end, so I've got to add 3 to this. And now that gives me my answer, x minus 2 squared minus 1. So I've completed the square. I've expressed f of x in this form, and that's the answer. And you can check your answer if you want to make sure it becomes that. X squared minus 4x plus 4 minus 1, x squared minus 4x plus 3. So this is the answer to part A. Okay, I don't know why they give us so much space for it, but that's fine. So x minus 2 squared minus 1. So that's just an alternative way of writing f of x. So I'll write it over here. So you have f of x equals x minus 2 squared minus 1. Okay, so that's the function f of x written in a slightly different form. Now it says it is given that f is a 1-to-1 function. State the smallest possible value of c. Now a 1-to-1 function is a function that for every input there is exactly one output. Okay, and there's not more than one input that gives you that same output. So for example, if you have a straight line, so I'm going to elaborate a bit on this because this is one of the questions that people do ask about. So for example, if I have a straight line graph, this is a 1-to-1 function. Okay, because every input gives you exactly one output, and all the outputs are different, okay, for each input, okay? You have a function which is not a one-to-one, okay, which is a many-to-one when you have something like this. For example, you have a quadratic. Okay, this, you'll see that for the same input, this value and this value, for two different inputs, sorry, you get the same output. Okay, so this is called a one-to-one function. This is called a many-to-one function. Okay, you have different terms, different values of x gives you the same value of y, many-to-one. That's a function, and that's a function. Here, every value of x gives you a different value of y. There's no two values of x that gives you the same value of y. That's a one-to-one function. Okay, and there's another type of situation which is not a function when you have something that looks like this. This is not a function. Why? Because there are multiple outputs for the same input. You can't have multiple outputs for the same input. That's not a function. That's like a one-to-many mapping. One-to-many. You can't have one-to-many. You can have many-to-one, or not one-to-many. This is not a function. These two are functions. All right? But it's told us that f of x is a one-to-one function. Now, when you have a one-to-one function, it doesn't go back on itself. Here we have a negative gradient, and then you have a positive gradient. When you have a one-to-one function, then it's either increasing the whole time or decreasing the whole time. It's not increasing for some values and decreasing for others. It's not going down and then back up again. Okay, that's not a one-to-one function. So if you have a parabola like a quadratic like this, and you have values either side of the turning point, that's not one-to-one. It's a function, but it's not a one-to-one function. That would be a many-to-one function. So as long as it is restricted to either side of the vertex, then it will be a one-to-one function. All right, so bearing all that in mind, okay, what we can understand is if I make a sketch of this function. Now, this question is only worth 1 mark, and as I said, I'm not going through it as if I would do in the exam. I know the answer just by looking at this. I can write the answer down, and that's all you have to do. But I want you to understand why that's the answer. I don't want you to just write it down and go to the next part and you don't understand what I'm talking about. All right, I've got questions of my students in mind when I'm answering this question. That's why I'm going into this detail. You don't have to draw anything in this question whatsoever. All right, you can just write the answer. Once I've explained it, you'll understand exactly what to write down without doing any drawing or any calculation. Okay, so state 1 mark, you can just write it down. As soon as you got it in this form and you know this, you can write down the answer immediately. But I want you to understand why. And to do that, making a sketch of this will be useful. So I'm going to sketch this function. Now, it's a parabola, it's a smiley face. It's going to look like this. Something like this, right? When y equals 0, okay, you have x squared minus 4x plus 3 equals 0. If you factorize it, in fact, we can do it this way, no problem. We can do it either way. You can factorize to solve. That's pretty easy. Minus 3 and minus 1. We could also use this. We could have said x minus 2 squared minus 1 equals 0. X minus 2 squared equals 1. X minus 2 equals plus or minus 1. So you end up with x equals 3 and x equals 1. Here, same thing. X equals 3, x equals 1. So I know it crosses the x-axis at 2 places, 3 and 1. So I can draw my x-axis. Okay, so that's going to be 1 and that's going to be 3. And I know it crosses the y-axis when x is 0, y is 3. So it's going to go through the y-axis at 3. So it's going to be something like this. That's going to be the y-axis. That's 0. That's 3. So that's how the graph would look if there was no restrictions whatsoever. Okay, that's how the graph of y equals f of x would look if we had absolutely no restrictions. And we would know that the vertex of this graph would be given by the coordinates 2 and -1. And we can read that from the form of this when you complete the square. So I'm going to also explain why is this the vertex from the quadratic, from the completing the square. How does the completing the square form make us be able to see the vertex straight away? Well, it's because of the form that it's written in. You can write this as minus 1 plus x minus 2 squared. So we can think about the value of this expression. You have minus 1 and you have plus something. And the thing that you're adding to minus 1 can never be negative because you're going to square that bracket. So whatever value of x you put in here, whether it's negative a million, positive a million, whatever it is, you're going to put the value in here, and if it comes out as a negative inside the bracket, you square it, it's going to be positive. So it's always going to be minus 1 plus something. So the graph will always be above minus 1. Minus 1. Okay? The lowest it can ever be is when you have minus 1 plus 0. Now, how does this thing become 0? When x equals 2. That's why 2 minus 1 is the vertex, which is the minimum point of this graph. Now, we mentioned that a function is a one-to-one function as long as it doesn't have a part that's falling and a part that's rising. It should be either all falling or all rising. Okay, the gradient should not be negative and positive. It should be just negative or just positive. Now, here they've told us that the domain is restricted to a value of x which is greater than c. So it's values which are on the right that we're restricted to. So what's the lowest that c can be? Well, it can be, the lowest it can be is going to be 2. Why? Because if you go lower than 2, the graph will turn back on itself and it will be many to 1. Okay? And it's not 1 to 1 then. For it to be 1 to 1, it can't have a negative and a positive part, so you've got to get rid of this. So basically, we've got to start from here. If we were to draw this, okay, there will be an open circle at 2 because it's not included, and we'll get rid of all of this side. This will all go because we've restricted the domain for x values which are greater than c. So c here is going to be 2. So we can say c is equal to 2. Now, I could have just done that straight away by looking at this. I could say, okay, the vertex has an x coordinate of 2, just by looking at this, and we are limited to values of x which are greater than, c, greater. We'll find the smallest possible value for c. That would be all the way up to the turning point. So x is greater than 2, all the way up to the turning point. Okay, and if you restrict the domain for x is greater than 2, you will get this shape, which is a one-to-one function. Right, so that question should take you just a second to do, but I wanted to explain the basis behind it. Now we're going to go on to part C. It is now given that c equals 5. So now we know that x is greater than 5. Okay, so if we go back to our graph will now be restricted up to 5. Now when x equals 5, okay, you're going to be over here somewhere. Okay, you're going to be over here somewhere. Now when x equals 5, you're going to have 5 minus 2, which is 3. 3 squared, which is 9 minus 1, which is 8. So it's going to go up to 8. I haven't drawn it very well. So it's going to go up to 8. Let's say we did this up to 3 there. We've got rid of this now. So this is going to start at 8. So now we're going to get rid of everything that came before it. Okay, we don't need any of that now. And this graph starts from here and it goes upwards. Okay, so that's how we can think about it. When we restrict it to x is greater than 5, it's going to start from here and it'll go up. It's going to be 1 to 1. Now, it says, find an expression for the inverse of f of x and state the domain of the inverse of f of x. Okay, so now, the inverse of f of x first. So let's take y and call it f of x. Okay, so we can say y is equal to x. Now remember, this was x minus 2 squared, and that was minus 1. Okay, x minus 2 squared minus 1. So when you have it written, and you have a quadratic written in the complete the square form, it's very easy to find the inverse then, because you only have one x term, okay, and it will make life easier for you. So you have y equals x minus 2 squared minus 1. So I'm going to now find the inverse by swapping the x and the y around. So I have x equals y minus 2 squared minus 1. I've got to add 1 to both sides, x plus 1 equals y minus 2 squared. And then I've got to take the square root of both sides. Now, what I'm going to write down here is y minus 2 equals plus or minus the square root of x plus 1. Now, I can't include both of them. I can't include both of them because that's a function that will be, well, it won't even be a function, right? It's going to look like that. So we can't include both of them. We have to decide whether we will take the positive or the negative square root for us to get the answer. Now, let me just finish this off. Y equals 2 plus or minus the square root of x plus 1. Okay, so now, in my answer, I'm going to write the inverse of f of x equal to, and I'll choose either the positive or the negative. Now, the basic rule is, if you have limited or restricted the domain to the right of the vertex, you're going to use the positive square root. And that's exactly what we've done. The vertex was here, and we restricted the function to the right of that value. So that means the inverse function is going to be 2 plus the square root of x plus 1. Now, if you were not sure about whether to choose the plus or minus, and you want to be 100% sure in the exam, then what you can do is you can choose a value of x within our domain. For example, we could choose x equals 6. Okay, and we can put 6 inside the original function and see what comes out. So if you put 6 inside the original function, you have 6 minus 2 squared. 6 minus 2 squared minus 1, which is going to be 4 squared 16 minus 1, which is 15. Now, if we have got the correct form of the inverse, when I put 15 inside the inverse function, the output should be what we put into it. So let's take first of all the wrong answer. We know that we're wrong, just to test it. So I have 2 minus the square root of x plus 16. Supposing I wrote this by mistake. I know it's not correct, but supposing I wrote that by mistake. Okay, I want to check if I've got the right the right expression. So what I can do is I can put, for example, as we mentioned, the number 6 into here. Okay, so if I put 6 into the original function, we get 15, right? Now, if I, if I put, I get 15. Now, if I put 15 inside the inverse function, okay, if I put 15 inside the inverse function, the wrong one, I'll have 2 minus the square root of 15 plus 1, which is 16, which gives you 2 minus 4, which is negative 2, which is not the correct answer that we want. Okay, that's not the correct answer that we want. But if we put the 15 into the one that we assume is correct, because we restrict it to the right of the vertex, we will get 2 plus the square root of x plus 1, which gives you 2 plus the square root of, that's going to be 15 plus 1, which is 16. Okay, the square root of 16 is 4, so that gives you 6. So the inverse of f of 15 gives you 6, and the original function 6 gives you 15. We know we have got the correct inverse. So we can say that the inverse, therefore, is equal to 2 plus the square root of x plus 1. And there's the answer to part C, except for we haven't quite finished because it says state the domain of the inverse function. State the domain of the inverse function. So we have to basically have a look at this. Now, what we understand, or what we should understand, okay, is that the domain of the original function, so the domain of the inverse function is the same as the range of the original. Okay, and the range of the inverse function is the same as the domain of the original. Okay, so the range of the inverse function is the domain of the original. So it's telling us here to state the domain of the inverse function f. So that's the same as the range of the original. What was the range of the original function? We can go back and see. The range of the original function was, when you restrict x to 5, it's going to be greater than 8. Okay, greater than 8. So we can say here that the domain of the inverse okay, is equal to the range of the original, which is, okay, we're going to write it in terms of x because we've got domain. X is greater than or equal to, no, not equal to, just greater than 8. X is greater than 8. There's your answer, okay, to part C. Okay, the domain of the inverse function is x and is greater than 8. So domain of inverse function x is given by this. Okay, so there's the answer to part C. Now for part D. It says find an expression for g of f of x and state the range of g of f. Okay, so now again, having f of x written in the completing the square form will be very useful here. So you have x minus 2 squared minus 4 plus 3, that's minus 1. That was the completing the square form. X minus 2 squared minus 1. Okay, so it says find an expression for g of f(x) and state the range of that function. Okay, so first of all, g of f(x) is when you take f of x and replace it instead of the x in the g of x. So basically f of x goes there. So I'll write it like that first. So I have f of x, 1 over f of x plus 1. Now f of x can be written in this form, which will probably make this a lot easier. So you have 1 over, in this form you'll have x minus 2 squared plus 1 minus 1, which is going to be 1 over x minus 2 squared. That is the function g of f of x. Okay, so we got g of f of x is equal to 1 over x minus 2 squared. Now it says state the range of the function gf. Okay, the range. We've got to find the range of that function. Okay, so we're going to think about the output of this function. Okay, you can think about this output of this function. Now, there's two ways I can think about this. Okay, there's two ways I can think about this. One way is to think about it in this way here, which I think I will show you first. So I can think of g of f of x as being 1 over f of x plus 1. 1 over f of x plus 1. Now, I know that f of x has to be greater than 8. Okay, that's the domain of f of x. Okay, that's the domain of f of x. All right, so f of x, sorry, the range of f of x, not the domain, the range of f of x. So whatever comes out of f of x goes into here. So the output of f of x goes in this place, and that must be greater than 8. So we can say that, we can say that the limits for g of f of x are, first of all, we can think about it when f of x equals 8. When f of x equals 8, you'll have 1 over 8 plus 1, which is 1 over 9. Okay, so that's when f of x equals 8. So we're going to consider the case not where it's equal to 8, or where it's, on either side of 8. Okay, of 8. So therefore, the range will be not including 1 over 9, it will be less than or more than, depending on the next part. Now, we want to also find the other limit of f of x, because we've looked at what happens when f of x is at its lowest kind of possible output that goes into here. Now, the highest possible output for f of x, the highest possible value that can go in here is infinite, because f of x is greater than 8, goes on forever. So I can write this as 1 over, okay, the limit as x gets closer to infinity of f of x and then plus 1. So this is going to be basically 1 over something really huge. This will be something really huge, because if you put f of x, sorry, this is limited as f of x becomes infinity. This becomes infinity. When f of x becomes really huge, then this becomes 1 over infinity, which tends towards 0. Okay, so our limits for g of f of x for the range are between 0 and 1 over 9. So that's one way of doing it. Okay, there's other ways which I'm going to also show you. For example, we could take the expression that we found over here, and we could think about the domain of f and the domain of g. The domain of f, as we were told, is x is greater than 5. Okay, and so what's common between these two domains? X is greater than 5, x is greater than -1. Well, it's x is greater than 5. That's what's common. So that will be the domain of g of f of x. It will be x is greater than 5, because that's what's common between them. So now, if I find out what happens to this when I replace the x with 5, I'm going to have 1 over 5 minus 2, which is 3, squared, which is 9. So I'll end up with, when x equals 5, g of f of x equals 1 over 9. And when now x can be infinite, can't it? It can go greater than 5 onto infinity. So when x approaches infinity, okay, then what's going to happen is you'll end up with g of f of x will approach 1 over infinity, which approaches 0. Okay, so it approaches 0. So that means g of x is kind of varying between 0 and 1 over 9, which is exactly what we found. So you can do it in two ways. By looking at the domain that's common between the two functions and thinking about what happens when you put those values in the algebraic expression for the inverse function, or so not the composite function, sorry. Or we could think of it in this form here. Okay, we can think of it in this form over here, and we can say, okay, what comes out of f of x will go in here. So what comes out of f of x can be just above 8, so this would be 1 over 9, okay? And it can be something close to infinity. F of x can be as large as you want it, which will give you 1 over something huge, so which is 1 over infinity, which gives you 0. So our limit, or our our range of g f of x is between 0 and 1 over 9. Okay, so that hopefully clears that up for you. There's different ways of dealing with these questions. So other questions from this particular paper can be found in the playlist that will appear in the top of the page over here. Other questions from the topic of functions can be found in the playlist that will appear over here. You can subscribe to my channel by clicking on this link, and you can watch the video that is linked here for you to be able to find out how to use my channel in an efficient manner. Thank you for watching, and see you soon.